Here we have a fictional data set that contains the pounds of butter consumed and someone's reported life satisfaction. So we're going to go ahead, let's create a scatter plot just to look at the data. So I'll select my data, including the headers, and I'll insert charts. I'll choose a scatter plot, and I'm going to click plus, add the trend line. So I can see there's some line. If the line is perfectly horizontal, that means there's no relationship at all. If there's some slope to it, either going up or going down, then that could indicate a relationship that's meaningful. Okay, so we have life satisfaction, and let's add axes, titles. So this is reported life satisfaction, and here we have pounds of butter consumed, and I hit the caps lock. Consumed. Okay, so I've got my chart there. It's always good to plot your data. So let's take a look here. We're just going to do a count up all those values. I'm going to copy and paste that function. Average all my pounds of butter. I can paste that over a column by peek inside. It's referring to life satisfaction. Excel updated the references for me. Now the standard deviation. So we didn't survey everybody in the world. This is just a sample. All right, 4.7 and 5.8 for my standard deviations. Confidence interval. So I'm going to use confidence.norm. My alpha will be 0.05, pretty standard for social statistics. Standard deviation, I've already calculated that, and the size, I've already calculated that too. It's my count. Okay, and so my lower estimate, so what's the kind of the true average, you could say? Let's see, I've got my average, and I'm going to subtract the confidence interval. And for the upper, I'm going to take my average, and I'm going to add the confidence interval. And I'm going to copy those and just paste them to the right. And I'll calculate the correlation here. Equals correl. Hit tab to autofill that for me. My first array will be the butter. Second array will be life satisfaction. So the correlation is 0.126. Not a super strong correlation. Actually fairly weak. You would probably not be able to report this in a scientific journal because you're not explaining very much life satisfaction. So let's say, can we use butter predict to predict somebody's life satisfaction? So with 4 pounds of butter consumed, what is this value going to be? I'm going to use forecast.linear here. So the new x that I'm predicting is 4. I've got my known y's, that's life satisfaction. My known x's is the butter consumed. And I shut that off. So that tells me if somebody eats 4 pounds of butter, so if I look at my chart, here's 4. Look at this line here. So that is like 10.6. I'm basically predicting a value on this line. So if somebody says 0, I'm going to be expecting 10. So if I change that 4 to a 0, yeah, it's going to be 10. And what's it going to be? About 12.5 for 16. Ballpark, yeah. So we're basically looking at values along this trend line for that forecast. I'm going to change it back to 4. So the standard error. So looking at this line, the standard error is basically telling me how far away from this line are each of my observations. And I can see they're pretty far away. So I'm going to say equals STEYX. So the known y's is life satisfaction. Known x's as butter consumed. Okay, that's a pretty big standard error for this data set. So let's see how far I'm going to be off for any one given prediction. So if butter consumed was 4, I'm predicting 10.6, but it's going to be between two values. There's going to be a range because my model is definitely not perfect. So the lower estimate, I'm going to say equals the prediction minus the standard error, and the upper estimate, I'm going to say equals the prediction plus, okay, my boss sharing something with me, plus the standard error. So what is this telling me? So for 4 pounds of butter consumed, this is telling me that, well, the real value is going to be somewhere between 4.6 and 16.5. Okay, so it's kind of like one horizontal bar here, so we have lines here. So 4.6 is going to be right around there, and 16.5 is going to be right around there. So not really close to this line. It's going to be not exactly on that line. It's going to be a pretty wide error. So when I have a weak correlation, this point 126 is a weak correlation, my standard error is typically going to be higher, and I'm going to have more error in my predictions, so the lower estimate and upper estimate is going to be higher.